Hi, this is Mr. Max. So today I am doing the sine rule, and we are particularly looking at non-90-degree triangles. This is part 2 of a 5-part series that I have on trigonometry. Right, so let me just get right into it. Suppose I bring this particular triangle here. This is triangle ABD. So what you can see from this particular triangle is that the angle at D here is 90 degrees. And if you are asked to calculate the sine of angle A, remember the sine is whatever is opposite, in this particular case h, over the hypotenuse. So that gives me sine A is equal to the hypotenuse, or the h over c, which is that height there. So when you make h the subject of the formula, you get that h is equal to c sin A. And I'm going to use this particular value here. So let me just expand that particular triangle, and I bring in triangle BDC, and also angle BDC here is 90 degrees. When you are finding the sine of C, the opposite, which is h over A, and when you make h over A, or when you make h the subject of the formula, you realize that the height is equal to A times the sine C. So there are two ways you can find the height from this particular triangle ABC. So if we then compare these heights, okay, with each other, like I did here, A sin C equals C sin A, and I divide both sides firstly by sin C and then by sin A, all right. When I divide by sin C, well, you will realize the sin C's cancel each other. So I'm left with C sin A over sin C. Right, so now I'm going to divide by sin A. So when I divide both sides by sin A, I have A over sin A, and I have C sin A here over C. When you are dividing by sin A, it's the same as multiplying by its reverse. So what I'm saying is this particular part here, if you have got sin C sin A and you are dividing, is the same then as multiplying by the inverse. So when you multiply by the inverse, all right, you will end up getting alone only the value of C over sin C, as you can see here. So this is basically how one proves the sine rule in a nutshell. So then if we continue the process and we do the same, we will get that A sin C, or A over sin A, equals B over sin B, which would be the same as C over sin C. Now what you can do as well is you can also swap them around, because you can equate them when you swap the fractions around as well. So in a nutshell, this is the sine rule is one that many students find easy and quick to remember. But the question is, when do you use which? It ultimately doesn't matter, but it always is important for you to know what to apply when you're dealing with the sine rule. So let me look at when we use the sine rule. So when you are given two sides, all right, or in an angle is not included. For example, this particular question here, you have got two angles in one side. So you can have another scenario when two sides and an angle not included between these sides is given. So you can be given a triangle, like for example, if I were to draw a triangle here, they could give you two sides. Maybe they give you side A here, and they give you side B, and then perhaps they give you another angle here. I'll call that angle theta. All right, so the angle is not necessarily included. The objective of the sine rule is for you to have one complete pair, an angle with a side, the side obviously being opposite that particular angle. Then you can calculate the other side, or the other angle, given that you have got that side there. So that is what this particular one mean here. But this example here, very quick one, is you're supposed to find BC. So you're given two angles here, and then you're given a side. Right, so what you do is you put BC, or this whole distance, over sine of 113 degrees, because 113 is opposite BC. And you let it equal to 18 over sine 41. Now sometimes it could be that they are asking you to find the angle at C. It could have been, again, as I'm saying, that let's take a rough example. Say they didn't give you the 18 here. And let's suppose they gave you here let's say they gave you 18 here as well. All right? And they wanted you to find BC still. Still, you're supposed to find BC. Then what you need to do, obviously in this particular case, is you need to subtract or find what is that angle equal to. All right, so you will have to therefore add the two other angles. You add the 113 and the 41, and then you get the third angle here. And when you do that, because remember all the angles of a triangle, they add up to, for example, 180. Now you have got a complete side, and you can actually then work with that. Okay, so now you have got complete side here, and then you can find that particular missing value or that missing side. So that is also one of the things you should be on the lookout for. All right, when you will now have to calculate this, you can definitely use the same. But this is not what this example was all about, though. This example was you had two angles and a side. All right, and the side is not included, it's not flanked by the angles. Right, so when you clean this up, you obviously arrive at 25.26 meters. Right, so I'm going to look at a few examples more in detail where we use the sine rule first to find an angle and then also to find the side. Right, so my first one is, how do you find a side? Right, so the first question says here, in triangle LMN, angle L is 60 degrees, angle M is 34 degrees, and Ln is 3.8 centimeters. You're supposed to find Mn. Now this question is given to you just like that, and it will be helpful if you could bring or draw yourselves a diagram. And it does not have to be a perfect triangle. It can be any triangle as long as you label it accordingly. And now you bring in the information you are given. Angle L is 60 degrees. Then they are saying angle M is 34 degrees. And then I'm given one more side. Right, so when I want to find a side, I must have two angles with a side that is not included in between that. Right, so I have a full pair here. So I have got an angle with a side opposite that angle. And so I will say Mn, therefore, over the sine of 60, because Mn is opposite that 60 degrees, is equal to the 3.8 over sine 34. Do you realize that when I'm looking for the sides, I put the sides on top? Okay? When I look for the sides, I put the sides on top. And later on, when I show you when we look for the angle, I'll put that sine angle on top. From here, it's easy. You just now get rid of this sine 60 by multiplying throughout by sine 60. This is going to be a punch in on your calculator. And make sure that your calculator is in degree mode. Right, so when you do it, you get 5.8851. And then you give your answer to three significant figures. For example, it will be 5.89 centimeters. So let me bring in a second question here. Again, we are given a question without a diagram. We're told that triangle PQR is Angle P is 120 in that triangle, angle Q is 20 degrees, and then we are given one side. So we've got two angles and a side. So again, it will be helpful if we can bring in a diagram. And I have decided to to have an obtuse angle triangle. It ultimately doesn't matter because the diagram is just a rough work, a sketch that you need in order for you to be able to put in the correct values as you are given, as you can see what I have done here. So your triangle does not necessarily have to look like this. These diagrams are not to scale. Right. The thing with this one is and this is exactly what I meant when I was doing the other one. We are supposed to find something that has to have a full pair. You have an angle here, but there is no side given. You have an angle here, but there is no side given. And here you have a side, but you don't have an angle that is given. So what is important here now is for you to calculate that third side, because that is going to allow you to find or to have a complete pair. All right, and when you do that, you will see that now I have got a 40, and now I have got a complete side of pair. I've got an angle, okay, of 40 degrees, and I have a side that is opposite that angle of 57 centimeters. And now I'm supposed to find RQ, which is this long side here, which means 120 degrees is coming into play, because 120 degrees is opposite that particular side, RQ. So it's very important that you also understand how to deal with this particular question. So when I bring in my solution here, again, as I said, I'm looking for a side, so I'm putting the sides on top. And RQ, the angle that is opposite RQ, is 120 degrees. And you equate that to 57 over the 40. And you multiply throughout by sine of 120 degrees. Well, you're going to get RQ is 76.79 and so on. And then you give this answer then to three significant figures, which is 76.8 centimeters. Right, so let's bring in a third example. So we are now going to calculate or to find an angle. So when we are finding an angle, we have to change our formula. So we are told that this particular triangle have got angle Q as 50 degrees, and then we're given two sides. All right. So the way you do this, again, as I said, bring in a triangle for yourselves, a sketch, and then complete the missing information. They're saying that P to R is 4 centimeter. They're also saying that Q to R is 5 centimeter. And then you are given an angle. Okay, so two sides and an angle. And if you look at it nicely, you have a complete pair here. You have got 50 degrees at angle Q, and the side opposite it is given as 4 centimeters. Now, because we're looking for an angle, we have to put the sine P on top. Remember, ultimately, it doesn't matter because you're going to have to do some sort of cross multiplication. So it doesn't really matter if you put the 5 and the sine P under and the 4 and the sine 50 under. All right, as long as you do find the angle P. But it will be helpful to know that when we're looking for an angle, then we put the sine of an angle on top of the side. Right, so that means I multiply by 5. Now I have to clean this up here, and I have to find this particular value here. And when you find that value, you get a ratio of 0.957 and so on. Now, in order for you to find the angle, you have to take your calculator and you find the inverse sine of that particular ratio. And when you punch that in, you're going to end up with an angle of 73.2 degrees, correct to one decimal place. So it therefore means if I have to bring that angle in here, this angle P is 73.2. Now, if I add these two angles and I subtract from 180 to find that third angle R there, I'm going to get 56.8 degrees. So if you add them all up, they give you 180. Now, the reason why I'm doing this is because of a little bit of an ambiguity. There is a little bit of a difference that you have to be very careful. There's an ambiguous case where you can have different angles here. We know that this is one solution. But let's talk about the sine ratio in itself. The sine of an angle is positive. You look at this ratio of 0.95, so on. This is a positive ratio. So the sine is positive in the first quadrant of your quadrant and also into your second quadrant. There is that cast diagram that we use, something that just help us to remember. So in the first quadrant, which is a solution of 73.2, but let us see whether it will be a solution also in the second diagram, which means we can also have an angle that is obtuse. All right, so once I subtract 180 minus my theta and minus my sine here, my angle of 73.2, I get 106.8. Now, if I want to make sure that 106.8 is also a solution, you take your calculator and you add 106.8, you add it to the 50 degrees that you were given. And if the answer is less than 180, then you have two solutions here. So let me bring in a rough sketch so you can see what I mean by that. So I have got an angle here that can be 106.8. I have my 50 here. The two of them do not add up to more than 180. So it means we can have a triangle where the angle is 106.8 or where the angle is 73.2, like what I have here. So we are going to talk briefly about that particular ambiguity. So be careful when you're dealing with such scenarios. So the first thing you do, if you take your answer and you subtract your answer from 180, and that obtuse angle that you find, you add it with the acute angle or the angle that you were given in your problem. And if that answer is more than 180, then it means you do not consider that answer that it's obtuse, but only one particular solution. But if that answer is less, like in this case 106.8, if you add 50 you get 156.8, which is considerably less than 180. And when that is the case, you definitely have two solutions to the problem. The triangle can either be an obtuse angle triangle like this at P, or it can be an acute angled triangle like the diagram here on top. So when we talk about that ambiguous case, I just want to emphasize that what I said in the beginning, you add the obtuse angle with the angle that you are given, right? And if you can do that, then you will definitely also realize that there might be two possible answers. So remember that when you're dealing with this type of question. So let me bring in a fourth question, and we are still trying to find an angle. So we have got information here that is given to us. It says that Christo is making a map of his local area, and he knows that the monument M is 460 meters away from his house, H. The spot center S is 406 meters from the monument. So please be careful when you draw your diagram that you don't confuse the measurements here. This is 460 and this is 406. And then they're giving us angle HSM, which is 70 degrees. Now I'm bringing in a diagram that I made. So we are supposed to find angle SHM. So what we are supposed to find is we are supposed to find this particular angle here. All right, so when we can find this angle, let's see what information are we given. Right, so if I bring in, I've given that angle 70 there, I'm given this distance here 460, and I'm given another side there. So what I have essentially is I have a completed pair here, a full pair. I have an angle and I have a side given to me. So I can therefore use my formula. All right, remember I'm looking for an angle, so S, the sine comes on top, sine of SHM over that distance that is opposite it, that angle, and then equal to sine of 70 over 460. So the first thing you do is you get rid of the 406 by multiplying throughout by 406. And then you get a value here. Now, in order for you to find the angle, this is the ratio here. To find the angle, you have to press the inverse button on your calculator, and then you find the inverse of that ratio, and you realize that you get 56 degrees here. Okay, so our answer is 56 degrees. So let's talk about whether we can still have another value. So let me just complete this triangle. So this triangle is 56 here, 70 here, and 54. The 54 I get by adding these two and subtracting them from 180. So just to test our previous theory of that ambiguous case, so we know that theta is 56 degrees. So if I subtract 180 minus that angle to C, because the sine is positive in the second and in the first quadrant. Now when I do that, I get 124. Remember what I said? You take the 124, okay, and then you are going to subtract it from the angle, or you're going to add it rather. You add this 124, you add it from the angle, or you add it to the angle that you were given in your information. All right, you add it to this particular angle. And when you do that, you realize that you are getting something that is more than 180 here. And if that is the case, then it means we only have one solution to this particular question. And therefore, the angle there is 56.0 degrees. Right. So I hope that the sine rule and the application of it is something that you now can master. And also what I would say is go back to the video, do a few questions that you have and see if you have caught on. I am going to post the cosine rule in the other video, in the other part of this particular series on trigonometry. All right. You can also join my Google Classrooms, and these are the codes that you have for grade 11 and for grade 12.